Well, welcome to the video. In this section is what, 9.2, where we're going to be looking at quadratic equations by graphing. So, in chapter 8, we looked at graphing quadratic equations. All quadratic equations are in the general form y equals ax squared plus bx plus c. All right. What I asked you to do was there were certain pieces that I wanted you to find. So in that, I asked you, okay, so I wanted you to find in those quadratics, like the first thing was tell me what A, B, and C equaled. All right. So that was going to be um, something that was, we could easily find um, through the equation. The second thing was determine what the y-intercept was for that particular equation, and it was always going to be 0 comma whatever the value of c was. And then we could graph that. Got the point. The third step was looking at the axis of symmetry, and that was the equation x equals negative b over 2a. The next thing was the vertex, where you took whatever the value you got for the axis symmetry, which was negative b over 2a, and then this is where you substituted that value in for x and solve for y into the equation. That's how we got our y coordinate plotted at that point. The fifth step, which is the new step here, is we needed to determine if there were any x-intercepts. All right, we never asked you to define where those points actually were. All right, now because it is a second degree equation, we have the possibility of having up to two solutions from x-intercept. So you could have two coordinates. You could actually have the potential to have one coordinate, or you could have the potential to have zero um, coordinates. So this means that it crosses the x-axis at two spots. This means it crosses the x-axis in one spot. Here's a little note. If it's only at one spot, the x-intercept would also have to be the vertex. So keep that in mind. And zero spots means it doesn't cross the x-axis at all. Throughout this chapter, we're going to be looking at different ways that we can solve for those said x-intercepts. And one of the ways that we can do it is by looking at the graph. All right. So when you solve a quadratic equation by graphing, what you're going to do is, if you notice, it's going to be set up as um, ax squared plus bx plus c, and the original equations could be set equal to 0. Anytime it's set equal to 0, that means we're trying to find x-intercepts. But to graph it, we need to replace 0 with y. Then what we're going to do is, since we have it as y equals ax squared plus bx plus c, what we're going to do is we're going to look at those 5 steps. Tell me what A, B, and C is. Tell me what the y-intercept is. Tell me what the axis of symmetry, the vertex, and then the x-intercepts if they have any. So what we're going to do is let's look at this one. So I have x squared plus 2x is equal to 3 by graphing. So what we need to do is we need to get everything on one side. So this turns into x squared plus 2x minus 3. And I'm going to put this as set equal to y instead of equaling to 0 right off the bat. Okay. So in this particular instance, a is 1, b is 2, and C is negative 3. So start my graph. So that's the first thing. Second thing is my y-intercept, and that's 0, comma, negative 3. So we'll say that it's right about there. Axis of symmetry, again, x is going to be equal to negative b, so it's negative 2 over 2a. So 2 times 1 is 2, negative 1. So if this is my negative 1, make my dashed line like so. X equals negative 1. My vertex. My x-coordinate comes from the axis of symmetry, so it's negative 1. To find y, I'm going to take negative 1, plug it into every value for x in the equation, solve for y. So negative 1 squared is 1, plus 2 times negative 1 is negative 2, minus 3. So 1 plus negative 2 is negative 1, and negative 1 minus 3 is negative 4. So negative 1 comma negative 4 is my solution. So it's just below my y-intercept. I can just plot that here to label it. A is positive 1, so I know it's going to go up like so, and it's going to go up like so right here. So I notice in the graph that I have two x-intercepts. I don't know what they are right now, but now what we're going to do is, for the fifth step, to find that x-intercept, what we're going to do now is, instead of writing this as y, we're going to write this as 0 equals x squared plus 2x minus 3 from that original equation up here. So now we get to factor. So we go 0 equals parentheses, parentheses, this is x, this is x. Different signs, plus, minus. Two values are going to be a product of 3, their difference is 2. Because the first sign is plus, the larger number goes to the plus, so it's going to be 3 and 1. 3 times 1 is 3. 3 minus 1 is 2. Zero product property tells me that x is going to be negative 3 and x is going to be positive 1. So what that is telling us here is that this coordinate looks like it's at the positive. This is going to be positive 1 comma 0. The reason why I can put comma 0 is because we put 0 in for y. This one here is going to be negative 3 comma 0. And now we've labeled all of our items, and here's how you graph it. So we have y-intercept, we have axis symmetry, we have vertex, and we have x-intercepts. So again, uh, these are very similar to what that was there. Again, if you have any questions, please comment. I am more than happy to look at these with you. So let's take a look at this one here. So it's got the negative. So now let's go negative x squared minus 2x minus 4, and that's going to be set equal to y. So let's graph this one. So A is negative 1, B is negative 2, C is negative 4. My y-intercept is at 0 comma negative 4, so let's just say negative, it's right there. Go with your label. Axis of symmetry, x equals 2 over 2 times negative 1, so that's going to be negative 2, so this is going to be negative 1. So axis of symmetry is x equals negative 1. Vertex is negative 1 is x because it comes from the axis of symmetry. So here I get negative 1 squared, which is 1, but then it's got the negative, so that's negative 1. Negative 2 times by negative 1 is plus 2 minus 4. So negative 1 plus 2 is 1. 1 minus 4 is what, negative 3. So negative 1 common, so it's just above the y-intercept here. A is negative, so it goes downward. So if you notice, the it does not touch the x-axis. So my x-intercepts are no solutions because it doesn't have any. And so that's how you can identify it with the graph. Okay. The last thing here is they gave us a graph, and it says the graph of this function, it says x minus 3 times by the quantity of x squared minus x minus 2 is shown. They wanted you to find the zeros of the function. Anytime they ask you to find the zeros of the function, they want you to find the x-intercepts. So what I notice is, oh, it looks like it crosses here, it looks like it crosses here, and it looks like it crosses here. All right, so it looks like -1, looks like 2, and it looks like 3. So if I were to put coordinates -1 comma 0, 2 comma 0, and 3 comma 0. If you wanted to verify that, what you're going to do is you're going to replace this function with 0. So I get 0 equals x minus 3 times by the quantity of x squared minus x minus 2. All right. This is already factored out completely. I think I can factor this out more. So 0 equals x minus 3. This turns into parentheses, parentheses, x and x. Different signs because the minus 2, large numbers attached to the minus in this case, so I believe it's 2 and 1. Zero product property, like from last section, x equals 3, x equals -1, and x equals +2. Here's my 3, here's my -1, and here's my 2. I was able to verify what my graph shown for that particular function. And that is being able to use the quadratic, be able to take quadratic equations by graphing. Hope this helps. Till next time.